pick 16F877A program memory map and stack. We discussed about stack in C programming when we discussed, we even tried by creating variables, local variables, and then we just printed their address in GCC right now to understand stack and those things. Do we have stack memory in microcontroller? Yes, we have, right? So, but what they told is program memory map and stack. In general PC, your program and data, everything will be in a same location, in the same RAM. But here, your program will be in program memory, data will be in data memory. Right now, they are different in microcontroller. So, in program memory itself, what they are saying, the program counter is 13-bit wide. So, it is pointing to both stack memory as well as the program memory. Stack memory is part of your program memory, right? Part of your program memory is stack memory. The stack memory is not only 8 memory location. 8 memory location means 8 instruction location. The stack memory can carry 8 program memory address. That's all. That is what they are saying. Stack level 8. Okay, if I try to push more than 8 memory location to the stack, what will happen? Your 8th memory location will be deleted and the very last that you uploaded, that will be at the top. So it is in that way it used to work, right? That is a stack memory. Without handling of stack, everything will be taken care by embedded C. You need not bother about that. Then it is also pointing the memory location from 0 to 1FFF. Got it, na? 1FFF, let us say. Let us check what is 1FFF. '8191. That's they told them from 0 to 8192. So each time when I increment a program counter, it will jump to 14 bits. Right now, in pointer that we discussed in GCC, every time we increment a integer pointer, it increments 4 bytes, 4 memory locations. Right now, if it is a character, whenever we increment a that integer character pointer, it increments 8 bytes. Right now, it jumps in the order of 8 bytes. Like that, whenever you increment your program counter, it will jump in the order of 14 bits. Got it now? How can we execute 14 bits? Actually, that memory location will be there. So they will, because the beginning will be, maybe they will do the 2-byte offset for every time they will increment the memory counter, they will increment the program counter by 2 bytes. So like that it used to work. So see here, your reset vector is 0. From there you have to start writing your program. Then in the interrupt vector memory address is 004. In that 004 memory location, specifically you have to say where they have to go if there is a interrupt. Then you have a program memory, no? Page 0, page 1, page 2, page 3. There are 4 pages, right? In these 4 pages, you can write your programs. this program memory and stack memories are two different things. So they are not overlapping each other. Make sense?
Yes, sir.
Okay. This is the memory map of 877A. So you understood now how to organize our programs in program memory. What are the things that we have to do? Those stuff are clear right now. Then
Yes, sir.
data memory organization. As we have a data memory, we have 4 pages, 4 banks in data memory too. All right. But what is the size of data memory? What is the size of data memory in our pick 16 of 877A?
Around 368 or something.
So actually 368. Yes. This many bytes only. 360 byte. Each bank that they are talking, right? They reserve 128 byte. 128. Come on. 128 into 4. I think I made a mistake. 128 into 4. 512. But we have 368 byte only, no? How that will work? But here they are saying program memory, okay, perfect. The data memory is partitioned into multiple banks which contain general purpose register and the special function register. Bits RP1 and RP0 in status register are the bank select bit. They helps us to select the bank. That is also okay. Each bank extended up to 7F, 128 bytes. Lower location of each banks are reserved for special function register. Above the special function register or general purpose register implemented as a static RAM. All implemented banks contain special function register. Some frequently used special function register from one bank may be mirrored in another bank for code reduction and quicker access. The EEPROM data memory description can be found in section 3.0 EEPROM data flash program memory of the datasheet. General purpose register file. The register, okay, there is some sort of discrepancy that we are seeing. What we have in the document is only 368, but they say here each bank extended up to 7F. Like that they are saying, no. So if that is the case, 4 banks, 4 into 128, we have to get 512. How that is possible, right? That is the question in our mind now. With that, we'll go here. So the each memory location is having 7F. Each bank is having 0 to 7F. If that is the case, totally 512 we have to get right now. But why we are not getting it? But that is not there. How we can get when the memory total data memory is only 368 byte, means how that is possible? Any idea, any thought from your side?
Not sure.
Hmm?
Not sure about it, sir.
Not sure.